Woohoo! Welcome back. Now we're going to be doing 6.5, sum of cubes and difference of cubes. And I'm not going to lie to you, this is probably no one's favorite set of formulas. However, they are a lot easier if you learn them together in a compare and contrast way. And I have a special guest support animal, support rock star, pop star to support you. It's Elton John, and he can sing The Circle of Math, and I will not try to sing it for him. So you just imagine he's singing all about the circle of math and how wonderful factoring and multiplying out and factoring again and multiplying out. It's just wonderful, isn't it? Everyone is happy. It's Elton John. Yay. Okay, so he's going to be just right over here thinking you're awesome, telling you can totally do it, but in a British accent. And you know, if someone tells you in a British accent that you can do it, you can do it. You have no choice. Okay, so we got Elton John. Sharktopus is also here. They both believe that you can do it. So let's take a look at these two formulas, the sum of two cubes and the difference of two cubes. So you'll see that I've written out one of my little cards with the colors and everything, and it's got arrows, and hopefully this will help make sense. So basically when you're factoring cubes, so what I mean by that is a cubed plus b cubed, or a cubed minus b cubed. So these are going to be very particular problems. We're going to recognize them really easily because first off, they're going to start off with two terms, and then they're going to have exponents that are cubes. And so you can imagine those will be multiples of 3. So generally speaking, we are going to be able to recognize them pretty easily for the most part. So, so let's go ahead and let's go into what the differences are. Pardon me. So if I start with a cubed plus b cubed, I start my factoring with just a plus b. It's a small one. It's another binomial. So a cubed plus b cubed becomes a plus b. A cubed minus b cubed starts off with a minus b. Do you see how it works? So you just take whatever you've already got written, get rid of the cubes. Now, the second factor is longer. It is a trinomial, and it's not one that we've studied already. It looks like one that we've studied. It looks like a perfect square, but what's missing? We'll do this Dora style. What's missing from these? This a squared minus ab plus b squared, or a squared plus ab plus b squared, that's not a perfect square trinomial because normally there's a 2 in there. This doesn't have that 2. So the good news is that once you factor into these two factors, these two pieces, you're done. So it doesn't go any further. That's it. You're done. So that's good. It's not like it goes on forever and ever and ever and ever. Well, at least it might feel like that. But remember, Elton John's got your back. Elton John's got your back. It's going to be okay. So let's take a look. A cubed plus b cubed, a plus b. And then we get into something that looks like a perfect square but isn't quite. It's a squared minus ab plus b squared. Now if we have a minus b, notice the here, it becomes a squared plus ab plus b squared. So in each case, there's one plus and there's one minus. And if we start with the minus, then we end with the plus. So that's the best way I know of to study these. So let's go ahead. You ready? We can totally do this. Factor if possible. Okay, so let's take a look at the first one. I've got x cubed plus 125. Okay. So we're going to look at this. We see it's a binomial. And how would we guess that it's a sum or difference of cubes? The answer is because it's x cubed, not x squared. So this first one is x, the quantity, cubed. Now the second one is 125. Is that a perfect cube? So what times what times what gives you 125? You're right. 5 cubed. 5 times 5 is 25 times 5 is 125. So this does break down into x cubed plus 5 cubed. Let's see if we've got that pattern. Then I'm going to write it out here because it's a lot. This is a lot. Okay, so I've got x cubed plus 5 cubed. So everywhere I see an a, I'm going to put an x. So I got an x there. I got an x squared there. And I've got an x there. And then b is going to be 5. So everywhere I see a b, I'm going to write 5 there, 5 there, 5 there. So take a look at that. And then I'm going to go ahead and clean that up. That's x squared. Usually we write the number in front of the variable, so I'll write it as minus 5x plus 5 squared is 25. And that's it. That's how you factor it. And I can already hear a lot of you saying, wait a minute, isn't this beautiful? Why would we do this? And the answer is, again, a Lego building you built may be gorgeous, but there are times when you need to take the Legos apart. And so this is the beautiful thing we've built, but then these are the individual pieces. And sometimes we have to break something down into smaller pieces. And we're going to get to that, later on in the class. So just believe me and Elton John. I know. Did you know he knew so much mathematics? I assume he does. He must, right? Awesome. Everyone who's awesome knows math, right? Okay, so, or is it everyone who knows math is awesome? I might have that one backwards. So we are going to have to use this occasionally. And just between you and me, for the most part, unless you're a math teacher, you probably will forget this formula after this class. So it's, have these formulas somewhere where you can look them up. Make copies of my cards, because as soon as the class is over, your brain's going to be like, I don't need that anymore. But it does come up that you have to use this. It doesn't come up every day, but if you're in a math class, it could come up every day. So just make sure you have copies of these formulas somewhere, just to reference in your next classes. Okay, shall we try another one? Yay! Of course we want to try more. More math means there's a better chance that it starts to feel more comfortable, right? Okay, so this is obviously not a sum of cubes. It's a difference of cubes because we got a minus there, right? So the formula we're going for would be a cubed minus b cubed. And again, I'm going to write this out because this is not simple. We start off with a minus b, and then inside the longer one, a squared plus ab plus b squared. Okay, so can we break this down into something cubed minus something cubed? And the answer is, I think we can. I think 8 is 2 cubed. So I think that's going to fit the pattern right there. Right? 8 is 2 cubed. Now 125x cubed, let's see. The 125 breaks down as a 5. 5 cubed is 125. X cubed breaks down as x cubed. So 5 times x cubed is 125x cubed. Okay, so our a is 5x. So we got 5x. And then, ooh, this is going to be exciting. 5x squared plus 5x times. And then my b is 2. Now notice there's a minus already built into the formula, so I don't have to worry about that. I just use a plain 2. So the b is going to be 2. So I get 5x minus 2, and then 5x squared, 5x times 2 plus 2 squared. And again, let's clean that up. 5x minus 2 times the quantity. Now, be very careful. Remember, when you square a term that has more than one factor, make sure you square everybody. So it becomes 5 squared, that's 25, and x squared. 5x times 2 is 10x. 2 squared is 4, and we're golden. Woohoo! I know. I readily accept that this is not going to be possibly anybody's favorite thing to do in math. Not even your second or 10th favorite thing to do in math, and that's okay. Again, this is going to come up rarely, but when it does come up, this is the only way to fix it. This is the only way. There isn't a really good workaround. Unless you go on, and if you keep working on towards math, we've got a math class called Math 90. And when you take Math 90, we're going to teach you kind of the original formula that, explains all the other formulas. We're going to give you the technique that will allow you to factor all of these without memorizing the formulas. But it is complicated enough that's going to take us a couple semesters to get you to that point. So for right now, this is what we've got. Okay? Okay. We could do it. Elton John thinks you can do it. Sharktopus thinks you can do it. I think you can do it. Dun dun dun! And I know you're all thinking, oh no, what happened to your paper? And the answer is, I spilled my water on my paper. And I don't know that I have a better version. Do I have a better version? Wait. Oh my goodness. Oh my goodness. It's a soft rock miracle. Okay, there we go. So, paper without water on it. I know, it's very exciting. So exciting, my cell phone got very excited to start focusing on, I don't even know, little pieces of atoms between here and the paper. Okay, so, what is even going on here? These are not perfect cubes. This is a mess. 128 y to the 7th minus 250 x to the 6th times y. What? This is a mess. Can anyone figure out what to do? And I know I'm trying to make it a thing. So if you were watching the last video, do you remember I said CFF? Common factors first. I don't know if it's ever going to work. So let's look for common factors. Okay, so, and I feel like Elton John wants to come in and tell a really bad joke and ask, why are folks living in Britain, I don't know if this is going to work, so good at factoring? Why are people in Britain so good at factoring, Elton John? Because, and I wish I could do an English accent, but I won't even try it for you, because they have the House of Commons to factor. Okay. Bye, Elton John. That wasn't as funny as I thought it would be on the outside. Okay, look for common factors. Here we go. 128 y to the 7th minus 250 x to the 6th y. Well, I see a common y. I can factor out a y. And this is an even number, and that's an even number. So I know 2 goes into both of them. So let me try factoring out a 2y from both of them. Okay, 128, if you're not sure, 128, factor out the 2, that leaves 64. Okay, so I got 64. If I pull out one of the y's, I've got y to the 6th. Minus, and 2 into 250, I know that one, 125, and I factor out the y, so I've just got the x to the 6th. And now, these are perfect cubes. I'm going to switch to brackets to make it easier. But I claim These really are perfect cubes. So let's look. 64. What is the cube root of 64? So if you look on your calculator, not all calculators will have this. Let me see if I can get this to focus up close. But my calculator, you see right there, it has the little box with a square root. Let me use the pen because that's going to be slightly easier. See that box with the what looks like a square root? You can do cube root. So on my calculator, if I'm not sure, let me see if I can remember how to do this. If I want to do cube root, I think I do second, and then this key. Oh, I lied. I do 3. Sorry, I forgot the 3. So cube root, second, get into this one. So it's the cube root of 64 gives me 4. So your calculator might possibly give you cube roots if you're not sure. Like what times itself 3 times gives you 64? And the answer is 4. Now, is it just 4y in there? Is that all it is? It's just 4y cubed? And the answer is no, because we got to y to the 6th. And y cubed is just y cubed. So what do I have to put in here? You're right. Nicely done. Y squared. Y squared times y squared times y squared gives you that y6. Okay. 125, the cube root. Do you remember the cube root of that one? You got it. 5. And again, we got x to the 6th, and that's x squared. And for this particular section, 6.5, you may want to just have a piece of paper somewhere where you just remind yourself 1 cubed is 1, 2 cubed is 8, 3 cubed is, you got it. Oop, let me make this turn 27. 4 cubed is, got it, 64. 5 cubed, we just talked about it, 125. 6 cubed, I think is 216. And then after a while, I start to forget. So you could do it on your calculator. You could bring in your calculator and be like, okay, 7 cubed is 343. Oh, I knew that. And I forgot it. So you may just want to have these numbers in front of you so that you can recognize, oh, 64. 64 is totally a perfect cube. That makes this section go a little bit faster. So, you know, if you want to jot these down really fast, all the perfect cubes, so that your homework goes just a little faster. Woohoo. Okay. So now this is complicated, but it doesn't have to be hard. You just have to be careful. I'm going to leave the 2y on the outside because that's part of the factoring. And then I'm going to remind myself of the formula. Now this one is the minus one, right? So I'm in the second one. So my first short factor is just these two, the difference of those two without the cubes. So 4y squared minus 5x squared. Okay, that's the first term. Now I'm already realizing I didn't give myself enough room. A great piece of advice that I should have given myself is, you know, when you're factoring, oh, this is just not speaking to me. When you're factoring, don't put an end bracket on it. Give yourself all the space. Okay, so now what am I going to have to do? Now this gets a little, again, take a deep breath. Have your support animals or, you know, pop stars nearby cheering you on. You can do it. You can do it. You can do it. Okay, deep breath. I have to take the 4y squared and I have to square it. Then in the middle, I take the 4y squared times the 5x squared. And then I take the 5x squared and I square that. See that? That's a squared plus ab plus b squared right there. Okay, and then I can close it. Okay, so 2y on the outside, bracket. This is nice and pretty. Nothing I need to clean up. Double check. No common factors, thank goodness. Okay, now, this is a lot. 4 squared is 16. Y squared squared is y to the 4th. Multiply these two together. The 4 times the 5 is, got it, that's 20. Now I'm going to do a little switcheroo here. Y squared times x squared, usually we put them in alphabetical order. Can you put the y squared first? Absolutely. I can't. And then 5 squared is 25. X squared squared is x to the 4th. Oh my gosh, you guys. Oh my gosh, you did it. And again, it's the circle of math right here. This is the multiplied out version. This is the fully factored version. And I know when you're looking at this, a lot of people are like, oh, that's so much better. Not. And the answer is, it is not prettier. I agree. I think this is just lovely comparatively. But this is going to be more useful. Again, Lego looks beautiful all put together, but if you leave all your Legos stuck together, then you can't keep playing with them. And so this is the form where we can actually break it up and see what's going on and use it to do something more. Okay, I'm going to need a big box for this. And I'm tempted to sing the Lo Hicimos song from Dora, but I'm not going to. But I'm going to say, you guys are awesome, and we did it. And Sharktopus is proud of you, and Elton John is so proud of you, and I'm so proud of you. You're awesome and amazing. Go get a drink, go get some vegetables, get some exercise, get some fresh air, get some sleep, and then, woohoo and math on.